All right, welcome to another video that we are doing on malware analysis. This is for the Intro to Malware Reverse Engineering course, and the textbook that we are working out of is Practical Malware Analysis by Michael Sikorski and Andrew Honig. As usual, we are working in our Windows XP virtual machine environment, and we will be looking at some malware. We have done our basic static, basic dynamic, advanced static, and advanced dynamic analyses. We know the all four techniques, so let's go back and look at some of the malware and use these techniques to really get an idea of what they are doing behind the scenes. We are in Lab 11 this time. Let's go ahead and do Lab 11-2. We're skipping Lab 11-1. We are doing 11-2. We're going to go ahead and start off in IDA. Okay, we are in IDA Pro. We are going to go ahead and open up our Chapter 11 lab. And we are going to do lab 11-02.dll. This is a DLL, not an exe. And the first question says, what are the exports for this DLL malware? Now, we could go into something like not PEview. We could go into Dependency Walker. However, we know that we're going to be working in IDA, and it does provide a method for looking at exports as well as imports. But we are only interested in the exports at the moment. Aside from our DLL entry point, which is not important, we have our installer. And that is the only export that we have in this malware. So, next is, what happens after you attempt to install this malware running rundll32.exe? So for that, we are going to have to set this up. First thing we are going to do is we are going to go into our machine. We are going to take a snapshot. That way, we have a restore point, because we are running malware. This is live malware that is going to do something on this machine. First thing that we do is we are going to go to our sysinternals. We're going to do ProcMon, which is the process monitor. And I'm just going to pause capturing. When you run process monitor, we saw this in our basic dynamic analysis, but I will just go over it again shortly. When you run process monitor, it is monitoring all the processes by default. There are a couple filters that it comes with, but by default, it is going to view a ton of everything going on the machine. It includes WinLogon, some of the background processes, some of the services, the VirtualBox services, because this is a VM. So we're just going to go through. We haven't run anything yet. So we are getting rid of that noise. We'll go back up to this capture button here and resume. So you can see that we are not capturing anything. The event count is going up, but these events are excluded from our view. We're going to go ahead and run a command prompt and change. Oh, and process monitor caught that too. We're going to exclude. And I am going to change directory into my D directory, samples, and we are in our Chapter 11 path. All right, now that we are here, we are going to have to launch that DLL. And again, that is a DLL. You can't just run it from the command line. In fact, let's run it from the command line, see what happens. Oh, we jump into CFF Explorer. That's interesting. I did not expect that to happen. All right, so we're going to have to run rundll32.exe. We are going to call the lab 11-02.dll. We're going to put a comma and then the import that we want to run. And was it install or installer? It was installer. And dropped us back to command prompt. Did it do anything in the background? Let's exclude that CFF Explorer. And it sure did. Boy, did it. So there is a lot going on back here. but there are a few very important things that we can look for that are create files, registry, create key. We can see a lot of open and query value. One of the ones that we want to really keep an eye for is reg create key. And we're just going to scroll through here until we find some of those. There we go. We have a reg set value. Let's see what we are looking at here. Ooh, okay. So we are in HKey, local machine, software, Microsoft Windows NT, current version, Windows AppNet DLLs. Now, we know this from the chapter. We know that this is a malware technique, and what it does is the AppNet DLL, when you have those, they will run any time that the user32.dll is loaded. So that is a persistence mechanism that malware uses. We can see that we have the registry type and the data. The data is spool vxx32.dll. That's interesting because it is not lab11-02.dll. Let's go ahead and do a search and do a find on spool vxx32.dll. Let's find out what else. So we have a create file. Let's jump through next. Query attributes. Write file. Okay. So we have created this spool vxx32.dll file, and I will spoil the ending for you. This is the exact same DLL as lab11-02.dll. I will leave it up to you to prove that. There are multiple ways you can do it, but that is outside the scope of what we are doing right now. What happens after you attempt to install this malware using rundll32.exe? Well, the malware creates a copy of itself in the Windows System 32 directory, and it sets itself as the AppNet DLL target. Question number 3. Where must lab11-02.ini reside in order for the malware to install properly? Well, that makes the assumption that we know that there is a lab11-02.ini file, and that we know that it prevents the malware from running properly. This is where we need to jump into IDA Pro. We can go into the strings and look for that INI file. We found it. We double click. We come down to the line here, and we can right click it and find our cross references to that operand. We find it in the DLL main, so we double click that, and here we are. So we are going to this INI file. We're checking to see if it exists, and there should be a jump if zero. There it is. Jump if 0. We go to that location, and it skips all of this here. So if the file does not exist, we skip. If it does exist, we read. So we know that we have to load this lab INI file, and that if it does not exist, we jump the rest of the code and we exit. But where are we looking for this code? Well, somewhere between the beginning and here. I'm going to guess this sub right here. And sure enough, we find the get system directory A call. So this gets the system directory on this version of Windows. It is typically in the Windows directory and the subdirectory system32. So the lab11-02.ini must reside in the Windows system32 directory, or this file, this DLL, will not execute any code. Let's go back. Question 4. How is this malware installed for persistence? Well, we saw that in question 2. It inserts itself into the AppNet DLL's registry key, and it is loaded into any process that loads user32.dll. Question number 5. What user space rootkit technique does this malware employ? So we're going to need to dive into this a little bit deeper. And one of the things that we can look at are the imports. So if you recall the information from the chapter, there should be some imports in this list right here that should jump out at you and tell you exactly how this malware is executing its user space rootkit activity. And the two that jump out to me are these suspend thread and resume thread. So this malware is utilizing the inline hook method to inject its code into that process flow. We don't know what it's doing yet, but we now know how it's doing it. So that leads into question 6. What does the hooking code do? So first we need to find where the hooking code is, and then we can find out what it does. In fact, let's hop over to the strings and see if we can find a DLL that it would like to interact with that isn't part of the imports that it uses, but it might be a DLL that it would intercept. And this WinSock32 DLL definitely looks like a prime candidate. So we'll double click that. We'll find our cross references. There is only one, and here it is. So here we can see the DLL that this malware is going to intercept the call to, and we know that we are going to intercept the send call to the winsock32.dll. At this moment, we don't really care why or what it's going to do when it does that, but later on in the lab, we will look at why it is intercepting this call. Moving on to question number 7, which process or processes does this malware attack and why? So let's just keep on scrolling up the code, and immediately we see EXEs. We have 3 executables called out specifically here. We have the bat.exe, outlook.exe, and msimn.exe. Now, we don't know for sure because we haven't analyzed the code, but we can make an educated guess that these are the 3 processes that we are interested in, or rather the malware is interested in, for what it is going to intercept that call to winsock32. These 3 processes are email clients, outlook.exe, that one's obvious. The bat is a third-party email program that I have honestly never heard of, and msimn is Outlook Express. So these 3 are all email clients. They would utilize the winsock32 DLL definitely for sending and receiving emails. And now that we are piecing this together, we're really beginning to get an idea of what this malware is trying to do, or at the very least, the environment that it is operating in. So question number 8, what is the significance of the INI file? Well, first of all, we have to look at the INI file. We're going to go into our samples, chapter 11, and here is the INI file. We know for a fact that for this malware to work, we have to put it in the Windows System32 directory. Let's go ahead and paste, and then arrange icons because Windows XP is the way it is. So we have our lab 11-02.ini. Let's open it up. It comes open in Notepad. So this is not a typical INI file. I don't know if you've been inside one or not. They are typically key value pairs. They are for saving settings. So you'll have something like execute malware equals true. Directory equals C:\Windows. Stuff like that. But this is just a string. It is a meaningless string. It doesn't have any value to us right now. We can't see exactly what the purpose or significance of the INI file is. But we know that if it is in the Windows System32 directory, that the malware will load it. So why don't we do some dynamic analysis? And we'll go ahead and open chapter 11, and we're going to open the DLL. Let's go ahead and click yes, and it's going to send it. It's going to stop at the module entry, which we like. We don't want it to run all the way. And what we're going to do is scroll through until we see, all right, so we've got our create file. We have our INI. Good. So we're going to read the file. Once we read the file, we are going to call. So keep in mind that the way that OllyDbg analyzes DLLs, your offsets, your line numbers, your, these values right here are not going to match in between IDA Pro and OllyDbg. So we will be jumping around by different addresses here. We can't say, all right, well, this executes at 1015.32. That doesn't exist over here. So we'll have to jump through our calls just like this. So 861OB3, 861OB3. So we're going to go here. We've got this bracket here that shows us we're in a subroutine. We've got a nice little loop right here. Let's set a breakpoint right here and just send it. So we've gone through our routine, we've done our loop, we've hit our breakpoint, and wouldn't you know it, we have spit out a pointer to an ASCII that is billy@malwareanalysisbook.com. So I would be willing to bet, because I've actually counted it out, that the length of this string right here matches the length of the encrypted string in that INI file. So here is your significance of your INI file. It has an encrypted email address in it. One more piece of the puzzle. So we are working with a DLL that injects itself into email applications, and it has an encrypted email address, and it intercepts calls to winsock32.dll. In fact, the send function of the winsock32 DLL. So at this point, it should be fairly obvious what this malware is going to end up doing, but we have one question left in the lab, and that is question 9. How can you dynamically capture this malware's activity with Wireshark? So this is where we get to really have fun with it. I'm going to close out of OllyDbg because we don't need it anymore. So remember, we did run the installer function of this DLL. It is installed effectively on this system. It is in that registry value where it's going to inject itself into anything that runs user32.dll or imports user32.dll, and it is going to specifically target outlook.exe. So all we have to do is satisfy the conditions of this malware, and it will do what it's intended to do. But first of all, we need to have an email that we can use. So I am going to jump over to Kali Linux that I have running in another VM. Just going to go ahead and log in. So I am logged into Kali Linux. This is a Linux distro specifically intended for malware analysis, penetration testing, all of the fun cybersecurity stuff that if you are getting into cybersecurity, you're going to be working with. But all I really need is something that can run Python. Anything that will run Python. The book, unfortunately, will suggest that you connect your Windows XP VM to your desktop and run the Python script on your desktop. I cannot recommend that. You never want to connect your malware analysis environment to your, what I call a production desktop, anything that you would care if it gets infected. So we know that the malware that we are analyzing is intended to be educational. It is not intended to be actually malicious. It acts like it will do malicious things, but it's not that malicious. It's not going to try and spread to everything that it can. However, just as a best practice, you want to get out of the habit of working with anything like this on your desktop. So I have spun up a separate VM, and utilizing the VM internal network, we have connected these two together. Good. My IP address is still set, and all I have to do is So we are going to run this command, and I'll break it down real quick. So this Python just means that we are running a Python script. We are invoking the Python environment. -m says that we are going to load a module. That module is SMTPD, which is the Simple Mail Transfer Protocol daemon. You don't need to know that, but you do need to know that SMTP is an email protocol. -n says that we are going to disable name lookup, so disable DNS essentially. -c is the class that we are going to be loading. It is debugging server. So we are loading the debugging server class of SMTPD. This is just a basic SMTP server that will authenticate everything, accept everything that you give it, but it's not actually going to email anything. The value that we're going to pass to it is this 192.168.0.69 nice:25. This is our IP address, the local IP address. We got that with IP ADDR, and it is right here. And the :25 is the port that it is running on. That is the standard SMTP port. So on our Kali Linux, we have an SMTP server running that will accept anything. Any login that we give it, it's going to say, yes, you are authenticated to use this server. Moving back over to Windows XP, let's launch Outlook Express. Sure, let's make it default. So the first time you launch Outlook Express, it's going to want you to set up an email address. We're going to do that very quick. And we are going to configure our server. The incoming mail doesn't necessarily matter, but we do have to configure it. So we'll do the same as our SMTP server. And there we are. And we will just put in a password because remember, it will accept any password that we give it. And we are finished. Next, we are going to spin up Wireshark. We're going to make sure that we select our VM internal network connection. And we're going to start capturing. Obviously, there's nothing going over that right now, so let's send an email. We're going to send an email to confidential@employer. We're not going to CC anybody. Here's our subject. Okay, so here is our email. We are sending it to confidential@employer.lol. This is a confidential email, is our subject, and of course in the body here is some really confidential information. Please make sure no outside parties know this information. When we click send, we're going to see that go over Wireshark. So just a quick overview of Wireshark. This is a sniffer that will tell you all of the packets that are going over the interfaces that you have selected for monitoring. We can see that from 0.100, that's our local computer. We are logging into the SMTP server. The SMTP server, which is 0.69, is sending back to us its information about what the server is. From us to the SMTP server, we are giving a hello and basic back and forth about who we are and what we want to do. We are mailing from davidk@malware.lol. Receipt to billy@malwareanalysisbook.com and receipt to confidential@employer.lol. Remember, in fact, we can go back to Outlook and sent items, open it up. We sent it only to confidential@employer.lol. Even though this got forwarded also to billy@malwareanalysisbook.com, even in the sent email, we don't see that because this was not intercepted at the application level. This was intercepted at the packet level with the conversation between the server. None of this information made it back to our email, so as far as we know, it only went to the email address that we intended it to go to. But in actuality, it was also forwarded to billy@malwareanalysisbook.com. Thus, we have completed the puzzle, we know exactly what this malware does, and we have seen it in action. I hope you enjoyed this video. I hope it helped you out. We are getting towards the end of the semester. We are getting towards the end of the module. We have a couple of labs left, and I look forward to seeing you on the next video.